Let us now name the sixth example. So we have in this case the cation, which is sodium. So let us first write sodium. Then in that case we have complex anion. So complex anion, how will we name? We will name the ligands alphabetically first. So we have two ligands. One is NO, which is nitrosyl, and 5-cyanide, which is cyano. So who comes first, cyano or nitrosyl? C comes first or N comes first? C comes first. So let us name the ligands alphabetically. So we will write sodium, then pentacyano. Pentacyano because we have 5 cyano groups, and 1 nitrosyl. So we'll write nitrosyl without space. Nitrosyl, and then we have iron. So we'll write ferrite. And we will calculate the oxidation number of iron in this case. So let us see what is the oxidation number of iron. We have 3 charge on sodium. So the anion will have -3 charge. So Fe -5, and nitrosyl, it will have 0 charge. So we'll write Fe -5 plus 0 is equal to -3. So Fe will come out to be 2 in this case. So ferrite in bracket will write 2. So this is how we'll name the compound. Then after this, let us go to the 7th example. So in 7th example, we have an iron. If you see carefully, it is an iron. 7th and 10th example, both of them are iron. So we will write the iron suffix at the end. So let us see how to name this. So in this case, we have 4 ligands. So we will write tetrachlorito. Then after that, let us see what is the charge on this. This is negative charge. So it is a complex anion. So we'll write nickelate. So we'll write nickelate because it is a complex anion. And then after that, we'll write the oxidation number of nickel. So Ni -4 is equal to -2. So Ni will come out to be 2. So this is the name. Tetrachlorito nickelate bracket 2. Why did I add this suffix 8? Because it is a complex anion. And let us write this one. This is an important one. So let us see how to write this. So in this case, we have cation, which is FeEn thrice, and anion, which is Cl3. So it is complex cation, simple anion. So first we will write the name of the cation. Now in this case, we have En as the ligand. En is ethylene diamine. It is already having di name in its own name. So because we have 3 ethylene diamine, so will we write triethylene diamine? It will not look good. So we will write, instead of tri, we will write bis, tris, tetrakis. Bis means 2, tris means 3, tetrakis means 4. So in this case we have 3 ethylene diamine. So we will use the prefix tris. So I will write the name of this compound as tris, referring to 3 ethylene diamine groups as ligands. Tris. Then now we have complex cation. So we will write iron. Tris ethylene diamine. So tris ethylene diamine. Then we have iron. What is the, in this case, iron is the metal atom. So will I write ferrite now? No. Ferrite I will write when this iron or the central metal atom is in complex anion. In this case, iron is in complex cation. So we will not write the suffix 8. We will just write the oxidation number of this iron in this case. So what will be the oxidation number of iron in this case? Chloride has -3 charge here. So this whole species will have. So in this case, the name of this coordination compound will be tris ethylene diamine. Tris because we have 3 ethylene diamines, and central metal atom case in this case is iron, and the oxidation number of central metal atom is 3. Why? Because chloride has -3 charge here, because we have 3 chloride ions. So this species complex cation will have +3 charge and En has 0 charge. So all the +3 charge will be on iron. So we will write in parenthesis Roman letter 3. So this is the name of this compound. Then let us name this compound now. Again, this is an important compound. So we have glycinato. This is glycinato, which is the ligand. So let us write the name of this compound. So initially we have in this case 2 glycinato. So we'll write in this case glycinato, we'll write bis glycinato, and then we have nickel. And what is the oxidation state of nickel? Glycinato has -1 charge. 2 glycinato will have -2 charge. So in this case nickel will have +2 charge. So we'll write bis glycinato nickel bracket 2. Then finally this compound, this is an ion. So at the end we will write ion. Here also in the end we will have to write this suffix ion. Whenever we have ion, we will write the suffix ion. So I forgot to write it here. In this case we will have tetrachloroto nickelate 2 ion. Whenever we have ion, in that case we will add the suffix ion at the end. So finally let us name this compound. So in this compound, this is the complex cation. So let us write this complex cation. First of all, in this case we will write the name of the ligands. Who are the ligands? Ammonia and chloride. So we'll write amine. A comes first. So we'll write pentaamine. So the name of this compound will be pentaamine without space, and then we have 1 chloro. So we can write chloro or chlorito, and then we have this. This is a complex cation. So we'll write ruthenium. Ruthenium. And what is the oxidation state of this ruthenium? So we have ammonia has 0 charge, -1 charge for chlorine. So Ru -1 is equal to +2. So Ru is equal to 3. So we'll write oxidation number as 3, and finally we will add the suffix ion because it is a ion in this case. So this is how we name the coordination compounds and the nomenclature of coordination compounds. So what are the rules for first writing the formula? We'll write the cation first, then the anion. The ligand name ends in O if the ligand is negative. The ligand name ends in IUM if the ligand is positive. And the ligand name of neutral ligands is their name itself, except for few ones like H2O, which is named as aqua, ammonia, which is named as amine, CO, which is named as carbonyl, and few others. Then we have, if we have more than 1 ligands, we'll write di, tri, tetra, penta, hexa. And for some ligands in which we already have the name di, tri, tetra, etc. So in this case, we will write the prefixes as bis if we have 2 ligands, 2 such ligands in which we have named di or tri or tetra, etc. So if we have 3 such ligands, we will write tris. If we have 4 such ligands, we will write tetrakis. If we have 5 such ligands, we will write pentakis, and so on. So how do we name the coordination sphere? For naming the coordination sphere, we will first write the name of ligands alphabetically. In that we will use the prefix di, tri, bis, tris, tetrakis according to the situation. Then if we have complex cation, then we'll write the ligand first, then the central metal atom, then the oxidation number of central metal atom in brackets in Roman letter. Then if we have complex anion, then we'll write the ligands first, then the central metal atom followed by the suffix ATE if and only if we have complex anion. And finally we will have the oxidation number in parenthesis in bracket in Roman letters. So that is how we name the coordination compounds. Finally, if we have an acid which is coordination compound, for example, we have this acid H4PtCl6. How will we name it? Acids, we have the name of the central metal atom followed by IC as the suffix. Only for coordination compound acid, we have central metal atom followed by the suffix IC and then acid. So let us see how to name this acid. So we'll write this as, in this case we have 6-cyno, so hexacyno. Then we have the central metal atom as platinum, so platinic we will write, because as I told you, for acids we will write the central metal atom followed by IC. In brackets we will write the oxidation number of central metal atom, which is 2 in this case. Finally, for acids we will use the suffix acid. So we will use 2 for suffixes. One is IC followed by the oxidation number followed by acid. So the name of this acid will be hexacyanoplatinic 2 acid. So this is how we name the coordination compounds. Now other than this, we have some other coordination compounds which are slightly complex, which are bridge compounds. So that we will name after. Welcome back dosto. Let us now see naming of bridging groups in polynuclear coordination compounds. What do we mean by this? Polynuclear. Poly means more than one. Nuclear means central metal atom. So polynuclear means the coordination compounds in which we have more than one central metal atoms. For example, if we take this compound, we have 2 cobalts, that is 2 central metal atoms. They are bound by 2 bridging ligands. What do we mean by bridging ligands? The ligands which act as a bridge between the 2 central metal atoms. They are called as bridging ligands. So we want to name these kinds of polynuclear coordination compounds in which we have bridging ligands. So what are the rules for that? So we use a hyphen, which is a dash, to separate the ligands. So we have one ligand here, so we are using hyphen, which is a dash, to separate the monodentate ligand with the central metal atom, and then we separate this dash again with another ligand which is connected to another central metal atom. So in this case we will use the symbol dash as a separator. Also we will use the prefix mu before the ligand. For example, in this case the ligand is amido, so we use the prefix mu. Then here we have another ligand which is hydroxo, we use the prefix mu. So this is how we name the polynuclear coordination compounds with bridging ligands in them. So the name of this compound, let us see how to do. For that, first we will calculate the oxidation number of the central metal atom. So how many central metal atoms we have? 2. So we have 2 cobalts in this structure. Then sulfate, each sulfate ion has -2 charge. So 2 sulfate ions will have -4 charge. Hence the charge on the coordination sphere will be +4. So 2 cobalt and NH2 group has -1 charge, OH has -1 charge, so -1 for each monodentate ligand. So En in this case has 0 charge, so we will have +0. That equals +4, which is the total charge on the coordination sphere. So 2 cobalt is equal to 6, which gives the oxidation number of cobalt as +3. So what is the oxidation number of each cobalt? +3. So let us now name this compound. We have 2 ligands in this case, 2 bidentate ligands, 2 ethylene diamine ligands. Because in this ligand we have the term di, because it is ethylene diamine. So we have the di symbol in the name of the ligand itself. Hence for bidentate ligands we use the prefix bis, tris, tetrakis. If there are 2 bidentate ligands, then we will use bis. If there are 3 bidentate ligands, we will use tris. If there are 4 bidentate ligands, we will use tetrakis. In this case, we have 2 bidentate ligands, so we will use the prefix bis to denote two bidentate ligands. Who are the bidentate ligands? Bis ethylene diamine. This is the ligand. Then we have the central metal atom, which is cobalt, whose oxidation state we calculated as +3. So cobalt 3. Why did we not call it cobaltate? Cobaltate is used only when the coordination pair, or we can say the anion, is complex. In this case, we have complex cation and simple anion. In this case, the central metal atom is in the cation and ligands are also in the cation. So we will use cobalt 3. We will not use cobaltate 3. So cobalt 3. Now, let us come back to our bridging ligands. We have two bridging ligands. One is amido group, another is hydroxo group. So we will use a hyphen as a separator. So cobalt 3, then hyphen. Mu is the prefix which we will use for the bridging ligand. So mu amido, and we will have a hyphen everywhere whenever we use bridging ligands. So hyphen, mu, amido, hyphen, then we have another mu because we have another monodentate bridging ligand. So another monodentate bridging ligand is hydroxo group. So hydroxo, mu hydroxo, then we have again two ethylene diamines, bidentate ligands. So we'll use the prefix bis to denote two bidentate ligands which are ethylene diamine. And finally we have cobalt 3 because we have another cobalt atom whose oxidation number is 3. And finally we have the sulfate group which we have in the anion. So this is the nomenclature of this compound. Let us use the same rule to name this compound. It is very easy. So we have in this case 4 H2O groups. That means tetra aqua. So tetra aqua. Now after that we have iron. What is the oxidation number of iron? So let us find. So we have one iron and one more iron. So 2 ions. And we have one OH group, so -1. One nitro group, so -1. And we have sulfate. One sulfate -2. Two sulfate -4. So we have the +4 oxidation state of the cation. So can you find the value of oxidation number of iron? So in this case, the oxidation number of iron will again come out to be 3. So let us calculate. 2 times Fe, -1 for hydroxo group, -1 for NO2 group, and that equals +4. So 2 Fe is equal to 6, which gives each Fe has oxidation number +3. So in this case, we have oxidation number +3 for this Fe also +3 oxidation number. So let us now name this compound. Tetra aqua. Then iron is in cation. This is complex cation, simple anion. So we will again use iron. We will not use ferrate. So iron, then oxidation number of iron, which is 3. Now let us come to the bridging ligands one by one. So first bridging ligand we consider is OH group. So mu hydroxo. Why mu? Because we have hyphen and mu as the separator. Mu is the prefix for the monodentate bridging ligand, because in this case we have a bridging ligand OH. So monodentate bridging ligand has prefix mu, and we have this dash as separator to denote the bridging ligands. Then again we have another bridging ligand which is NO2. So mu nitro. Then we have another iron. So we'll have tetra aqua, which is 4 ligands, followed by iron 3, and then the simple anion which is sulfate. So this is the nomenclature which we have for polynuclear coordination compounds. After this, let us take the example of ambidentate ligands. What do we mean by ambidentate? Just like we have terrestrial animals and aquatic animals. So terrestrial life, aquatic life, and the life which can exist both on land as well as in water is called amphibious species. Amphibious means who can exist on both land as well as water. Similarly, ambidentate ligand. Ambi means it can donate through 2 sites. Just like amphibious means they can live in 2 different situations. Similarly, ambidentate ligands are those ligands which can donate a single lone pair through two sides. For example, we have nitro group and nitrite group. Nitro is NO2, nitrite is ONO. If nitrogen donates a lone pair to form a coordinate bond, then we have nitro as the ligand. And if oxygen, in the same kind of structure, if oxygen is the atom donating the lone pair to form coordinate bond with the central metal atom, then it is ONO. This is ambidentate ligand, because in this case we have the same formula NO2. But in one case nitrogen is the donor of lone pair, another case oxygen is the donor of lone pair. So these are two ambidentate ligands. So let us see the nomenclature of ambidentate ligands. So let us consider this ion, COONO NH3 2 plus. So it is an ion. So what will be the name? Let us name the ligands alphabetically. We have nitrite and ammonia. So amine and nitrito. So first amine comes. So pentaamine, nitrito. In nitrito we have the donor as oxygen. So we'll write dash O dash. Then central metal atom, which is cobalt, and the oxidation number of cobalt we can calculate. It will come out to be 3 very easily. And it is an ion. So we'll write ion as the suffix. Similarly, if we have this ion, CONO2 NH3 2 plus, then what will be the name? We will have the pentaamine nitro, because in this case we have nitro group in which nitrogen is the donor. So dash N dash cobalt 3 ion again, because again the oxidation number of cobalt we can calculate easily. It will come out to be 3, because CO minus 1 is equal to plus 2. So CO will come out to be 3 in both the cases. So that is how we name ambidentate ligands coordination compounds and polynuclear coordination compounds. So these are various rules which we have to apply for nomenclature of coordination